Hi everybody. This is going to be the first time with you that I've done a lesson, put it on video, and posted it to the classroom so that you can watch it outside of our class time and take the notes, get some basic information so that you can come into class ready to work on problems. And I don't have to spend classroom time in front of you doing a lot here. I'm not trying to use this to take the place of my instruction or my teaching. It's just a place to get notes so that when you start working on problems, I'll be visiting the whiteboards and your groups to help fine-tune some of your questions. So I hope you bring in questions, and I'm going to build upon this as the next couple of weeks go along. Today's we're just going to start out pretty quick, pretty easily with not a real lot of information. Section 3.3 deals with slopes. We've been working on lines and parallel lines and transversals. And so that the next place that we go in geometry starts to apply some algebra concepts, which involve slope. And when we have a line, we can deal with slope of a line. And on the coordinate plane, we can use the points of data, the data points or the coordinate points. So, first thing I want you to do, you have the paper from class that you're going to use in class on Wednesday, which is today. I'm filming that today before class. And then on the back of it, you'll see where it says notes for homework. And these are your guided notes, your definition of slope, so you have a definition. Remember I did a little lesson on definitions the other day. Slope. In the coordinate plane, it's the ratio of change along the y-axis to the change on the x-axis. And so how that might look is if you have 2 points, and here is our line, here is our change on the y-axis. It goes from this point to this point up, so whatever that y is, and then the change in the x-axis, it goes from here to here, and there's our x. So it's the change in y over the change in x. Y minus y over x minus x. So, here is the next part when it says finding slope of a line. Here's a teaching problem. If you've been given these 2 points, -1, -2, and 3, 3, what's the slope of the line that's gone through those points? Remember, what you want to make sure you know is change in y over change in x. So our change in y's would be -2 minus 3. Change means we're subtracting, so we take our first of the y's, take away the next y. So -2 minus 3, and then over the change in x, -1 minus 3. Be careful of your negatives. Make sure you're using your negatives the right way. So the slope of that line is positive 5/4. -2 minus 3 is -5. -1 minus 3 is -4. Negative over a negative makes it positive. Okay? So there's that element of this. I forgot to add, please, when you're watching this, feel free to pause it at any point to make sure that you've got all the notes down. So if you need to go back and pause it, please go back and pause it. Types of slope. For a positive slope, here's our axis, and it's going to have an uphill rise. Our negative slopes we'll have a downhill. They go downhill. So you can put those in underneath. Then we have the zero slope. And there's that. Our zero slope is horizontal. And our undefined is vertical. Straight up and down. We have perpendicularity right there. Okay, so those are those parts. We've got about 4 minutes left. Slopes of parallel lines. Let's talk about it. When we have parallel lines, and actually that's not a real good picture. I'll show you. Maybe they have them parallel like this. Remember from class today that parallel lines, they're indicated by having the arrows on them. This shows that they're parallel. The slopes of parallel lines has the same slope. Okay, they have the same slope. You learn that in Algebra 1. Here's an example. When you have y equals 1/3 x plus 4, y equals 1/3 x minus 5. The slopes are the same so that they're at the same angle, the same rise and run. They are parallel and will never rise. Remember, this is your intercept. This is where it's going to cross the axis, the y-axis. Then we get to perpendicular lines. And this is what you can write in. They have a negative reciprocal. And here's the example. Here's a visual of it. There's our axes. There's one line, and then there's the other line, and that they have a right angle. They're perpendicular. And here are the two examples of that. So y equals 1/3 x plus 4. I should add, I apologize here, negative reciprocal slopes. Y equals negative, this is positive, so we make it negative, 3x minus 8. Whatever, the y-intercepts don't matter on this. It's with the slope, because that tells you the steepness of the line. Positive slope, negative reciprocal. If this was a negative slope, then we would change it to positive, the opposite one. Okay? So, on Tuesday, when you come in after the long weekend, I hope you have a good Columbus Day weekend, we will be working on problems in class, and you're going to be expected to kind of have this for notes so that you can refer back to these in your groups, where you'll be collaborating on some longer problems. Okay? So, go back and watch any of this if you need to. If you're absent, you can watch this and have at least your notes down for everything. This is the first time we're doing it. I kind of took more time to go over it. When next time I'll just jump right in. Okay? Have a nice weekend, everybody.